The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today, eventually, we're going to go on and cover section 11.5. But first, we have a Webassign request from a student. So we'll start with that. And this is from section 11.4, number 16. And let's take a look at, well, actually, before we take a look at it, I want to ask you something. So the slope formula says m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2, y sub 1, x sub 2, x sub 1. What do all those little subscripts mean? In other words, is y sub 2 the same thing as y sub 1, or are they different? Anybody? No one wants to say? Well, they're different. They refer to different coordinates of different points, don't they? So the subscripts make a difference in something, right? Okay, I wanted to point that out because let's take a look at the Webassign problem. Write the logarithmic equation as an exponential equation. N equals log base b of r sub 1. Now, b to the n equals r is wrong, but what's wrong with it? They left off the subscript of the 1. So that's the only thing wrong with that, okay? All right. So basically, let's go back here for a moment and take a look at this screen where we have n equals log base b of r sub 1. So that would be b to the n equals r sub 1. Okay, that takes care of that question. Now, let's go on. Unless there's a question about that, we good to go? Okay. So let's take a look at.
I'm sorry, Mr. Mayo. Yes, there actually was. So I knew that I was missing the 1 in that equation. I was just unsure of how to input that into Webassign. I emailed you back, but you may have not seen.
I did see it, and you said something about doing it in Webassign, but for me, okay, not a problem, not a problem.
Thank you.
You betcha. We will take a look there, see if I can. Give me just a minute here. Let's see. And that was from 11.4. Okay. I'm going to see if I can pull that up. I know you can't see what I'm doing here yet. Let me just get to it. See if I can find a similar question. 16. Good. I think this is the exact same problem. Okay. So let's take a look at number 16. And our answer should be b to the n equals r sub 1. So I click on that, and I got b to the n, and then over there equals. Now I need a subscript. This isn't going to do it. So I got to look here. Let's see, functions. Here we go. That's what I need right there. See how it says sub? So I'm going to put in a capital R and then hit that and put in the 1. All righty.
Okay, I went through all those functions and I could not figure it out, but
yeah,
there it is.
Okay, all right.
Thank you.
Good? We good?
Yes.
Okay. So now let's see here. Let's go back to my whiteboard screen. And we're going to take a look at section 11.5. Now, we've looked at the compound interest formula, which was what? A equals P times 1 plus R over K to the KT power. And K was the number of compoundings per year. So if it was annually, K was 1, semi-annually, K was 2, quarterly, K was 4, monthly, K was 12, daily, K was 365. Let's talk about the population in Yakima County. Now, I don't know whether it's increasing or decreasing, so I'm just going to make some assumptions just to make a model here, but let's say that it's increasing, okay? Is this the way that the population increases? Starting on January 1st, nothing happens, nobody dies, nobody's born until December 31st at 11:59 p.m. All of a sudden, a bunch of people die and a bunch of babies are born, and there's more babies born than people die, so the population increases. Does it happen just instantaneous right before the end of the year? No, it's an ongoing process, right? If you look in the paper every day, there are births and there are deaths. So it's a continuous process. Now, when we've got something that's growing or decaying continuously, there is a irrational number that we use the letter E to represent, all right? And let me backtrack a little bit. Pi is a number we use that is approximately 3.14. Pi is used when we're dealing with circles or spheres, round objects, okay? E is an irrational number, approximately 2.7. We use E when we're talking about a population that is continuously growing or decaying, okay? So if we've got continuous growth, continuous interest being compounded, continuous decay, we use the letter E, which again is approximately 2.7. So pi is a little more than 3, E is a little less than 3, okay? Where is E on your calculator? Well, on my particular calculator, to find E, let's go back to, we had the button that says log, and the second function was 10 to the x. Right below it, there's a button that says ln, which stands for log base E, and we will talk about that eventually. But the second function of that is e to the x. So let's say I want to get just plain old E. How would I do that? On my calculator, turning it on, clearing it, I would go second, and then the ln button, which basically accesses e to the x. So I'll go second ln. When I do that, this is what shows up, e to the what power? Well, if I just want e, I put a 1 in there and then close it up and push equals. And I get 2.7, 1828, 1828. Now, this is deceptive because it looks like there's a block of 4 digits, the 1828, that repeats. But if we had 1 more or 2 more placeholders on our calculator, we would see that after that, it doesn't repeat, okay? But E is approximately 2.7 though. Okay, now, what I want to do next is I want to graph y equals e to the x. So to do that, give me a minute here and let's see if I can get this to work correctly. Right, and I want, let's see, 10:57 a.m. This, okay. So do you now see on your screen f of x equals 2 to the x and a graph of that?
Yeah.
I just want to make sure I'm pushing all the right buttons here. Okay, so what I'm going to do, we've got the graph of f of x equals 2 to the x. Let's look at the graph of f of x equals e to the x. Now, again, e is approximately 2.7. So the graph should look very much like 2 to the x, but it should climb a little bit steeper. Okay, a little bit quicker. All right. So f of -3 equals e to the -3 power. So on my calculator, I'm going to do the second ln. So I've got e to the, and I'm going to put -3 in there and close it up. And I get 0.04978, blah, blah, blah. I'm going to call that 0.05, okay? Which is approximate, and I can't graph it more accurately than that on the stuff I've got anyway, okay? Let's find f of -2. So e to the -2 power is approximately 0.135. So I'll call that 0.14. Again, rounding to the nearest hundredth. We okay? All right. F of -1 is e to the -1, which is 0.367. So we'll call that 0.37, rounding off to the hundredth. What's e to the 0 power going to be? So f of 0 would be e to the 0 power, which is 1. F of 1 is e to the 1, which is e, which is approximately, let's see here, 2.718, so 2.72. Again, I'm rounding each of these roughly to the nearest hundredth. F of 2 e squared is 7.389, so 7.39, and e cubed is 20.085, so 20.09. Okay, so again, that's rough estimates. So when x is -3, y is like, wow, it's just almost at the x-axis. Then -2, it goes up a little bit. -1, it's about a third. 0, 1, it's there. 1, 2.7 is about there. 2, it goes all the way up to 7.39. And at 3, it goes all the way up to 20, so it's off the graph, okay? So again, it looks very similar to f of x equals 2 to the x, but I just wanted to show you what it looks like and also talk about how you get it on the calculator. So any questions about that? All right, so now we're going to go back to using the whiteboard. So let me change the screen. All right, can everybody see the whiteboard again? Somebody?
Yeah.
Okay, thank you. Thank you. All right. Now, so there's a formula that says A equals PE to the RT. So this is P times E, and the E is raised to the RT power, okay? P would be the initial population or the initial amount. E is not a variable. Remember, E is roughly 2.7. And then R is the interest rate or the increasing rate or decaying rate. And T is time, typically in years. So we've got this following problem. It says, find A using the formula, given the following values of P, R, and T. P equals 5,000. R equals 8%, T equals 20 years. It says round to the nearest hundredth. All right, first of all, I'm going to change 8% into a decimal, 0.08. Okay, so A equals 5,000 times E raised to the parentheses 0.08 times 20. Now, if I want to, I can predetermine what 0.08 times 20 is, or I can just put parentheses around the whole thing. I'm going to just leave it. So in my calculator, I'm going to put 5,000. Okay. Oops, 5,000. Now I need to access E, so I'm going to push the second function, and then I'm going to push the ln button. So when I do that, I now should have this on my calculator. Okay, any questions about that? So now I'm going to put in there 0.08 times 20, close it up, 0.08 times 20, close it up, and then push equals. And I get, what's that? Question?
No, sorry.
Okay, sorry. So I get 24765.16212, and it said, oh, what did it say? Round to the nearest hundredth, which would be right there. The 2 would round down. So 24,765.16 would be the answer. Any questions about that? Okay. Let's take a look at another example using the same formula. In this case, P is 15,895, R is -2%, and T is 16 years. -2% is -0.02. So what do you think the -2% represents? What's going to happen in this case? Is this thing going to grow or shrink?
Shrink.
Right, right. So A equals 15,895 times e to the -0.02 times 16. And if you need me to write out the keystrokes on the calculator again, I will. Otherwise, I'm just going to go ahead and do it. So 15,895, second ln gives me e to the, and then I've got -0.02 times 16, close it up, and I get 11542.138. The 8 would round up, so you'd get 11,542.14. You okay with that? Any questions there? All right. Now it says evaluate each expression without using a calculator. But before we do that, let's review something and look at something new. LOG is the notation used for log base 10. Base 10 is called common log. It's used a lot in mathematics. Well, log base E is also used a lot in mathematics, but they've already used LOG as their shortcut notation. So somebody decided that we're going to call log base E natural log, and we're going to write it like this, LN. I don't know why it's not in L, but maybe it's log NHRL or something, I don't know. But anyway, so LN equals log base E. So you need to know this and you need to know that. Again, on your calculator, this button has e to the x as a second function, just like this button has 10 to the x. So that second function should remind you what that is. Okay. All right. So it says evaluate each expression without using a calculator. The natural log of e to the 5th power. That's the same thing as log base e of e to the 5th power. Okay, because this is the same thing as that. All right. Now, I'm going to say that that's equal to some unknown answer box. If I take this logarithmic equation that I've now created and use the converting it into an exponential equation, it becomes e to the box equals e to the 5th power. Therefore, the box equals 5. So the natural log of e to the 5th power equals 5. Any questions about that particular example? Okay, let's take a look at another one. The natural log of 1 over e cubed. Well, that's the same thing as log base E of 1 over E cubed. We'll call that some unknown answer box. Now we have a logarithmic equation. We could write it as an exponential equation, e to the box equals 1 over E cubed. But I could write 1 over E cubed as e to the -3 power, moving the base up above there. We're not used to making something with a negative exponent. We're used to going the other direction. But now the box equals -3. Any questions about that problem? All right. How about this one? The natural log of the 5th root of E. Well, that would be log base E of the 5th root of E. That's equal to some unknown box. Changing it to an exponential equation, we get that. But isn't the 5th root of E equal to e to the 1/5 power? So the box is 1/5. Okay. Let's see here. How about this one? The natural log of e to the -10 power. That's log base E of e to the -10th power. That's equal to some unknown. So e to the some unknown is e to the -10. So the unknown is -10. Right now it says use a calculator to evaluate each expression if possible. Express all answers to 4 decimal places. All right. So we've got the natural log of 35.15. So on my calculator, I'm not doing the second function key. I'm pushing the LN button. So I get that. Then I put in 35.15. Close it up and push equals, and I get 3.559624618, but it said around to 4 decimal places. The 2 would round down, so 3.5596 would be the approximate answer. Any questions about that? Okay, how about the natural log of -10? So natural log -10, I get domain. Oops, error. Again, remember the base of the log has to be greater than 0 and not equal to 1. The quantity you're taking the log of has to be what? Greater than 0, right? So you can't take the natural log of -10. Okay, or how about this one? It says solve each equation. Natural log of x equals 2.6490. You should notice that this assignment is very similar to a previous assignment. In fact, like as in yesterday's assignment, except, or was it 2 days ago? Except that we're using base E, log base E to just kind of get used to that. So if the natural log of x equals 2.6490, that's like saying log base E of x equals 2.6490. So that means e to the 2.6490 power equals x. Well, on our calculator, now I'm going to do second ln. So I've got e to the, and then I put in 2.6490, close it up, equals, and I get 14.1398968. Let's see, the 9 would round up, so 14.1391. And that's again to the, let's see here, where did I get this from? Oh, that's an 8, so that should be a 9. Sorry, couldn't read that. Rounding to 4 decimal places. Okay, Any questions about that? All right, finally warming up in my basement. Now, this formula that we've looked at previously is for compound interest that is not continuous. This formula is for when it is continuous, okay? Now, here's a question. The title says continuous compound interest. An initial investment of $2,000 earns 8% interest compounded continuously. What will the investment be worth in 15 years? So immediately, we're using this formula, not that one, because it says it's compounded continuously. Okay, so an initial investment of $2,000, so that's P, earns 8% interest, so that's R, which we convert into a decimal, compounded continuously. What will the investment be worth in 15 years? Okay, so A equals $2,000 times e to the 0.08 times 15. And as I mentioned before, we could predetermine what 0.08 times 15 is if you want to, but don't round it off to something, keep it exact. All right, so 2,000. And then what? Second function key, ln function key. So I get 2,000 e to the, okay? And then in there I put 0.08 times 15, 0.08 times 15, parentheses, equals, and I get 6,640.233845. But it says, oh, so we're talking money here, right? So unless it says otherwise, we'd round off to the nearest cent, which would be right there, because this is dollars. So A is $6,640.23. Okay with that? Any questions there? All right, let's take a look at another example. This says determining the previous balance. An account now contains $3,610 and has been accumulating interest at 8% annual rate, compounded continuously. How much was in the account 4 years ago? All right, so because it's continuous, we're going to use this. But it says an account now contains. So we're talking, it's like Jeopardy. We know the answer. We got to figure out what the question is. So the principal is the question, the unknown, okay? Interest rate is 8%. And the time is 4 years, okay? So we're working backwards. We now have that much. How much did we start with? In this case, because I'm going to be dividing both sides to get P by itself, I'm going to predetermine what 0.08 times 4 equals, and that's 0.32. Okay. So now I'm going to divide both sides by e to the, whoops, to the 0.32 power. Those were reduced down. So P equals 3610 divided by e to the 0.32 power. So 3610 divided by e to the 2 power. And I get 621.398024. This is money. So we'd round to the nearest cent. The 8 would round up. So the initial amount was $2,621.40. So that's what they started with. Okay. Read the questions carefully. Students often miss this question because they don't read carefully. They treat it as though this is P and they're looking for A. So read the directions carefully. Okay. Any questions about that one? All right. Let's see here. This next problem says bed bugs. Ugh. If not checked, the population of a colony of bed bugs will grow exponentially at a rate of 65% per week. If the colony currently has 50 bed bugs, how many will there be in 6 weeks? So we're talking about a population, right? So it's going to be growing or decaying continuously. And in this case, it says it's growing. So we're going to use the formula A equals P e to the RT power. If not checked, a population of a colony of bed bugs will grow exponentially at a rate of 65% a week. So R equals 65%, which is 0.65, and that's per week. If the colony currently has 50 bed bugs, so the beginning, I guess, so there's 50 bed bugs, okay? Says, how many will there be in 6 weeks? So this problem, time is in units of weeks. So it's growing at a rate of 65% per week for 6 weeks, okay? How many will there be in 6 weeks? So A equals 50 times E to the 0.65 times 6 power. So 50 second ln is 50 e to the 0.65 times 6, close it up, equals 2,470.1224. And let's see, where did this go? So rounding to the nearest bed bug, we'd say about 2,470. If that doesn't make you hesitate about getting into your bed tonight, I don't know what will. Okay. Any questions about that problem? Okay. Here is another example. This says the Big Easy. I'm not sure about that reference. I think it has something to do with New Orleans because it says, New Orleans has steadily won back some of the population it lost in the wake of Hurricane Katrina in 2005. If the current 8.2% annual increase in population remains constant, how long will it take for its population to double? All right, so we're talking about a population that's increasing since it's a continuously growing process. It's going to be this formula, okay? Let's see, the current annual increase in population, so R is 8.2% or 0.082. Be careful with that conversion. How long will it take for its population to double? So the population, we don't know its population, do we? And time is the unknown. Time is the unknown. In fact, let's do this. Let's put a question mark there. We don't know the population, but they want it to double. So the ending amount, which is A, should be double the starting amount. So A would be equal to 2 times the initial population. So even though they didn't give us the beginning or the ending population, they told us it was going to double. So you okay with that so far? Well, let's find out. All right. So using this formula, A is going to equal 2p, pe to the r, 0.082 t. Let's see here. Do that. I should. So this is 0.082 times t. Okay. Or we could say 2p equals pe to the 0.082 t. Now, what am I trying to solve for? I'm trying to solve for t. Can you see that I could divide both sides by p? I don't know what p is, and I got to be careful that I'm not dividing by 0, but if the initial population was 0, how would it double? So it can't be 0. Doesn't make any sense, right? Oops. So drop my pen there. So I've got 2 equals e to the 0.082 t. You okay with how I got here? Any questions? I now have an exponential equation where the unknown is the exponent. How could I isolate that exponent? By using logarithms. So this is going to be log base e of 2 equals 0.082 times t. Okay, so I switched it from exponential to logarithmic equation form there. But log base e of 2 is the natural log of 2 equals 0.082 times t. To solve for t, I'll now divide both sides of the equation by 0.082. So t equals the natural log of 2 over 0.082. And let's see what that is. Natural log of 2, close it up, divided by 0.082. Comes out 8.453014, etc. And they don't tell us where to round, but I see that they rounded to the nearest tenth of a year. The 5 would round up, so it's going to be approximately 8.5 years. Okay. Any questions about that? So I have a question for you. Let's take a look at this. Well, in fact, let's leave it on the same screen. What is it we wanted to do? We wanted to double the initial population. Okay. And here we have the natural log of 2. What is this? 0.082. That's the growth rate. Well, I didn't even know what the initial population was or the ending population. All I knew was that it was going to double, right? So it really didn't matter what quantity we started with, because I'm going to be doubling it. When I get rid of the p on both sides, I'm going to have this. So in fact, there's a formula that says this. The doubling time of something growing continuously is equal to the natural log of 2 divided by the growth rate. So we could have saved some time and just said, oh, it's going to be, putting this number in and gone right to the answer. Let me ask you this. What if they wanted to triple the population? What if this was 3, this was 3, this was 3, this is 3, this is 3, this is 3, right? It'd be the natural log of 3 divided by it. Okay. Well, let's put that to use on this problem. It says doubling money. How long will it take $1,000 to double if it is invested at an annual rate of 5% compounded continuously? Now, that's the key, though. It's got to be continuously. So we're using this formula. But because we're doubling it, okay, it says how long, so the time would be the natural log of 2 divided by the annual rate, which is 5% or 0.05. So natural log of 2 divided by 0.05 equals 13.86 years, and they say they round it to the nearest tenth of a year. Okay, now I could do it the long way, and I could say $2,000, because we're doubling it, equals $1,000 times e to the 0.05 t. Then we could divide both sides by $1,000, and we get 2 equals e to the 0.05 t. Then we get log base e of 2 equals 0.05 t. Natural log of 2 equals 0.05 t. Divide by 0.05. T equals the natural log of 2 over 0.05. So basically you could say, well, I don't really need this formula, but it sure saves a lot of time. So I think it'd be a good idea to use it. But when does it apply? When you've got a continuous growth situation and you're asked to double. How long does it take to double the population? Okay, so 11.5 for tonight. And don't get behind, because tomorrow we're going to have 11.6, just a little bit, one formula from 11.6, and then we're going to use that also on 11.7 in the chapter review. Thursday we'll review, Friday you'll take your chapter 11 test, and then Monday and Tuesday we'll review for the final, which is on Wednesday. I will be back today at 1:15 with an office hour. Should you have any questions, I'll go ahead and stop the recording.